Hi and welcome to my calculus clinic. This is Dr. Ghada Nakla. Today we are going to look at integrating special integrals. And these integrals look like the numerator being the derivative of the denominator. So when you differentiate f of x, you get f prime of x or f dash of x. And if the numerator is the derivative of the denominator, then your integration is, so if you have integration in the form of where the numerator is the derivative of the denominator, therefore your answer is ln your denominator, which is f of x plus c. Let's apply this to a few questions and see how it works. So question 1. Let's look at this question. Now let's take a look at f of x, which is the denominator, and the denominator is x squared plus 1. Let's differentiate and find f prime of x or f dash of x. And if I differentiate x squared, I get 2x. If I differentiate plus 1, I get a 0. So the derivative of the denominator is 2x. Now let's take a look at the top here at the numerator, and I only have x. I don't have a 2x. So what do I actually do? I'm going to multiply by 2 over 2, which means 2 divided by 2 is 1. So this means that I have multiplied my question by 1, and anything in mathematics multiplied by 1 stays the same. So now I have the numerator as 2x. So I can, in fact, say that my answer is, so I am integrating 2x as the numerator divided by x squared plus 1 dx. And this 2 will come out here as a half. Now let's go back and see, is the numerator the derivative of the denominator? And the answer is yes, it is. Therefore, my answer to this integration is ln half, leave the half alone, and then ln mod of x squared plus 1, which is my f of x plus c. And that's the answer. So half ln mod of x squared plus 1 plus c. Let's look at a slightly different question. Question 2. And I'm integrating 3 over 3x plus 5 dx. Okay, let's take a look at the denominator, and if the denominator is 3x plus 5, I can say it's y or f of x. Therefore, f prime of x, f dash of x is, or the derivative, or dy by dx, if y equals 3x plus 5, therefore dy by dx is 3. The derivative of 3x is 3, plus 5 disappears into 0. Is the top the derivative of the function at the bottom, or the denominator? And the answer is yes. Therefore, my answer is ln mod 3x plus 5 plus c, and that is my answer. Okay, let's take a look at something slightly different. We're on question 3 now, and I want to integrate 1 over x minus 2 over x plus 3 dx. And this is the same as integrating 1 over x dx minus the integration of 2 over x plus 3 dx. I can split the integration in 2 halves. Okay, and then I'm going to start integrating. And when I integrate, 1 over x, I get ln mod of x plus c, but we're going to put the c at the very end. 2, I can kick the 2 out of the integration. And then I end up with, if I kick the 2 out here, so I end up with 1 over x plus 3. When I differentiate x plus 3, if f of x is x plus 3, therefore, the derivative of the function is 1. Therefore, the numerator is the derivative of the denominator. Therefore, it's ln mod x plus 3 and then plus c. And that is my answer. ln mod of x minus 2 ln mod of x plus 3 plus c. Let's take a look at something slightly harder. We're on question 4. And we are integrating cos 2x divided by 1 plus sine 2x dx. Okay, so if I imagine that my f of x is 1 plus sine 2x, then I need to differentiate this. So f prime of x, f dash of x equals 1 will differentiate into 0, and then sine, what does sine differentiate into? Sine, cos, minus sine, minus cos. You differentiate this way. So sine differentiates into cos. So it's going to be cos kx, right? Because I have a k, I'm going to put a 2 here, a k. So sine kx differentiates into 2 cos kx, or 2x. K is 2. Right, let's go back to our question and assess the situation. Is the numerator the derivative of the denominator? And the answer is no, it's not. I'm looking for 2 cos 2x, but I only have cos 2x. So I need to multiply by 2 over 2. Now the numerator is 2 cos 2x. So now I can write it as a half, and then the integration of 2 cos 2x over 1 plus sine 2x dx. Is now the numerator the derivative of the denominator? And the answer is yes, it is. So it's ln whatever is at the denominator, f of x, whatever f of x is, plus c. So leave the half alone and then integrate ln 1 plus sine 2x, mod 1 plus sine 2x, plus c. Let's take a look at something slightly different. I think, yeah, that's the answer here. I think we're on question 5. And this time I'm integrating x over 2 minus x and 2 plus x dx. Okay. Right. Before we start, let's try and think, what is 2 plus x and 2 minus x? This is what we call the difference between two squares, if you remember from GCSE, 2 minus x and 2 plus x. Alternatively, what you can do is you can expand the brackets. And when you expand this, you're going to get 4 minus x squared. And we call it the difference between two squares in mathematics. I'm sure you've come across it at some point during year 9. Okay, I'm going to rub it off because the computer doesn't seem to like it. It keeps moving. Right, okay. So this is the same as 4 minus x squared dx. If I imagine that my f of x is 4 minus x squared, then my f dash of x is 4 will differentiate into 0, and I'm going to be left with minus 2 x. X squared differentiates into minus 2x. You drop the power and then decrease the power of x. So minus 2x. Okay, right? Is the top the derivative of the bottom? And currently it's not. So what do? I make it the top. Make it equal to minus 2 over 2. Multiply by minus 2 over minus 2. Okay, therefore, this means that my question now will be, I'm integrating minus 2x over 4 minus x squared dx, and I also have minus a half, which is this half there, this minus a half. So minus a half goes into the integration, and minus 2 goes into the integration, and the minus half is kicked out of the integration. Is now the numerator the derivative of the function of the denominator? Yes, that's the numerator, that's the denominator. Therefore, the answer is ln whatever f of x is. So minus a half, and then the answer to the integration is ln mod of my function, my f of x, plus c. Okay, let's take a look at something slightly different. We are on question 6 at the moment, so let's take a look at 6. Something slightly harder, and this time I'm integrating x plus e to the 2x divided by x squared plus e to the 2x dx. Okay, let's imagine that my function, my f of x, is x squared plus e to the 2x. If I differentiate this, what do I actually get? I get x squared becomes 2x plus e to the kx is differentiates into k e to the kx. And k is 2. So x squared differentiates into 2x. You drop the power and then decrease the power by 1. So 2 minus 1 becomes 1, plus e to the kx differentiates into k e to the kx, and k is 2. Right, now I need to take a look at the top. Is the top 2x plus 2e to the 2x? Is it? And the answer is no, not really. It's not, right? So what do I actually do? I want it to be 2x plus 2e to the 2x. What do I need to do? I need to multiply by 2. Can I just multiply by 2? I can't. I have to multiply by 2 over 2, because this means I'm multiplying by 1. And when you multiply anything by 1 in mathematics, it stays the same. So basically, I have not changed the question. 2 over 2 is 1. So let's go back to my integration. And I am integrating 2x plus 2e to the 2x, which is basically the product of this, 2 multiplied by that. I think I've messed it up here, so let's rub it off. Yeah, so it's the product of multiplying the 2 by the numerator. Okay, and the other 2 comes out of the integration as a half, and then divided by x squared plus e to the 2x dx. Is now the top, the numerator, the derivative of the bottom, the denominator, is the top the derivative of the bottom? And the answer is yes, it is. Therefore, half stays the same, and your answer is ln f of x. Whatever f of x is, just write it down there, plus c. Half ln mod of x squared plus 2x plus e to the power of 2x plus c. Okay, let's take a look at something slightly different. I think we're on question 7 at the moment. And I'm looking at integrating 3 over x ln x dx. Okay, this one is slightly tricky. Now I need to identify f of x, and let's say that if f of x is ln x, this means that f dash of x is equal to 1 over x. Is the numerator 1 over x? And currently it's not. And is the denominator ln x? Again, it currently isn't. Now, how do I do that? I'm going to divide the numerator by x, and I'm going to divide the numerator by x and the denominator by x. So this means I will have 3 over x. Let's kick the 3 out of the integration. I'm going to have 1 over x at the top, and I'm going to have ln x dx. So at the top, kick the 3 out. At the top, there will be 1, so there will be a 1 here. So it's going to be 1 divided by x, okay, which is there, 1 divided by x. And divide the denominator by x, and therefore you'll end up with x ln x over x. So you'll have, as the denominator, you're going to have x ln x divided by x. So these x's will cancel. You'll end up with ln x. Is now the numerator the derivative of the denominator? And the answer is yes, it is. Therefore, your integration is ln whatever is at the bottom. So it's going to be 3, leave the 3 alone. And the answer to the integration is ln mod f of x, which is ln x. Plus c. And that's my answer. ln x plus c. Let's look at the last question we are going to do today. And I'm integrating cot x dx. From memory, I think this is in the formula book, but you need, just in case you're interested to know or find out where did they get these answers from the formula book. Now we all know that cot is what? Tan is sine of cos. Cot is 1 over tan, and therefore cot is cos x over sine x dx. Now imagine that your f of x is the denominator, which is sine x. So f dash of x is, I've got the sine, cos minus sine minus cos. I differentiate this way. So when you differentiate sine, you get cos x. Is the numerator the derivative, the differentiation of the denominator? And the answer is yes, it is. Therefore, my integration is equals ln mod of sine x plus c. And that's how they got it in the formula book, because the top is the derivative of the bottom. That's all we have time for today. I hope you have found this video useful, and I'll see you at the next video. Bye.